Okay, we're back. Here we go. Here was my nemesis, and I hate it when I do that. When I'm like, and then I get back to my office, I go, oh yeah, that's how you do that. Probably because you were watching my thought process there when I was going through that, and I was missing some basic things here. I was trying to make it way harder than it needed to be. All right, so here's the question where we've got omega V max, which is equal to omega times alpha, is equal to 1.6 meters per second. And I've got A max, which is equal to which is equal to A omega squared, which is equal to 7.63 meters per second squared. Okay? Now, let me show you what I was thinking on this problem. I probably want to shrink this down just a little bit more. All right, so there's the data that we have so far. Okay, so there's the data. There's what we know so far, and we can solve omega for this. I mean, it's staring me right in the face. But first, I want to talk about what we mean when this thing, again, if this is my displacement, I can never draw. I always make this one too fat and this one too small. But it's, if this is displacement and this is time, okay, and then down here, what I have again is what I'll have here is this is velocity over time. But each one of these, as it goes through here, this wave, the angle that it goes through is equal to 2 pi. This angle that it goes through is equal to 2 pi. Okay, so if I put these two on top of each other, this is what I was doing in class, and I know you guys are going, what the hell is he thinking? So this is what I was doing. I was putting the x, here's this one right here, and then here's my velocity one, because when x is equal to 0, the velocity is at a maximum, so it'll come down like this, and right here. And actually, it's a little bit different. It's a little bit smooshed, but the acceleration thing goes to the same thing. So when this is so it's right here at this point, and this is 1/4 of the way through 2 pi. It's 1/4 of 2 pi. So you multiply that out, and you wind up with pi over 2. Well, or it's at the 90-degree point right there, because this is 1/4 of the way, so it equals pi over 2. So I've got to get omega times t, where the difference between the two, which is what the problem was asking, is got to equal pi over 2. Well, how the heck do I get the omega? Well, that's easy. Look, they did it for us. They told us what omega was. We got to tease out that information, and what they said was omega, alpha times omega, is equal to 1.6 meters per second. Therefore, alpha omega squared, which equals 7.63 meters per second, is equal to 1 omega times alpha times omega times omega. And this is 1.63. Well, how? Omega then equals 7.63. For some reason, I was not getting it 1.6 meters per second. Divided by 1.6 meters per second. And we're done. And then you figure out, you plug that omega, that number that you get right here, and solve for t. It's goofy numbers, but that's all it is. That's all it is. I was like, gosh, dang. But I guess it's good for you to watch me fail every once in a while. So let's go to my second failure today. It was very embarrassing.